Let's derive a formula for the electric field due to a dipole. I start by drawing two charged particles. The absolute value of their charge is the same. Particle 1 is positive and particle 2 is negative. Let's call the midpoint between them point C. And let's call P the point where we want to calculate the electric field generated by the dipole. Now we represent the electric fields as vectors starting at point P. Particle 1 generates a field directed upward from point P, since it is positive. The field generated by particle 2 points in the opposite direction. This sketch is not drawn to scale. Vector E2 should probably be drawn with a smaller arrow than vector E1, since the module of a vector field is inversely proportional to the square of the distance. But as we shall see later, distance d is actually quite small. Let z be the distance from point C to point P. And let d be the distance from one charged particle to the other. Now we write the expressions for the electric fields generated by particles 1 and 2. In order to do so, we need the distances of each particle to the point P. Particle 1 is at distance z minus half the size of d. I forgot to mention it, but here I consider all these vectors to be in the direction of the unit vector, y, or y-hat as some prefer to call it. The distance between particle 2 and point P is z plus half the size of d. Just to remember, these charges have the same absolute value. Here we apply the superposition rule. Field E is the sum of fields E1 and E2. E2 has negative sign because it is opposite to E1, and E1 goes in the positive direction of y-hat. Now we can start our high school level algebra. Let's factor out common terms. Here I write the constant k as 4 times pi times the permittivity constant. Let's apply more high school level algebra in order to deal with these fractions. Now we expand the terms on the numerator. We distribute the minus sign. I'm doing it slowly so you can see all the steps. As you can see, many terms will cancel out. We will factor out the term z from the denominator. This is basic algebra again, but it can be tricky. So let's do it slowly and separately. Any term squared is just the product of it by itself. We factor out z squared from the first term. And also from the second term. two factors of z squared, which amounts to z to the fourth power. Since exponents distribute over multiplication and division, we can group z with d over 2. The product can now be simplified to just one term squared. And that is it for the denominator. Now we have a z to the fourth power, which simplifies nicely with that z on the numerator. Let's reorganize things a little. Q times d has a special meaning. It is called the electric dipole moment. A vector quantity pointing from the negative to the positive charge in a dipole. If distance d is meaningful to the problem, then this is the equation we should use. But in most situations, d will be meaningless compared to z. Think of it as if point P were zooming out from the dipole. Then the fraction d over 2 times z can be approximated as 0. So now we have our final expression for the electric field of a dipole at a point P significantly away from the dipole itself.